Okay, and we continue with our program, moderated by Professor Günther Müller-Ziegan, Professor of Water Infrastructure and Director at the Institute for Sustainable Water Systems at Hof University of Applied Science. The following panel discussion will address the urgent need for urban transformation to tackle the challenges posed by extreme weather and foremost rainfall events. The title of the panel is UrbanWater 2030, Water Solutions for Resilient Cities Facing Climate Change. The session will combine international insights from research and industry, while exploring the role of policy instruments in the successful implementation of resilient sponge cities. Experts will discuss holistic, innovative solutions, practical strategies and interdisciplinary collaboration to create water-sensitive urban environments equipped to face the impacts of climate change. We are going to look at the impacts of climate change to cities and the impacts of water solutions for resilient cities. We are looking forward to an exciting discussion on our three main topics: climate-resilient urban planning, technological innovation, data monitoring and digital solutions, and the financing and governance aspects, as well as future perspectives. And now I hand over to our panel moderator, Professor Günther Müller-Ziegan, who will introduce himself and the five panelists to you and guide you through the discussion. We thank you in advance and look forward to examine together the challenges and how we can work together to build water-sensitive cities resilient to climate change. Please feel free to write your questions into the chat in the pinned box right next to the screen. We will try to include them during the panel in the discussion rounds for each of the mentioned three main topics. Professor Müller-Ziegan, the floor is yours.
Thank you very much, Boris, for this very kindly introduction. So we can directly connect to one of the last questions where it was named that Sponge City is a holistic concept, and this is exactly where we want to talk about. So as presented, my name is Günther Müller-Ziegan and I'm from University of Hof, and we have the first competence center of Sponge City and Sponge Region in Germany, and we focus especially on the connection between cities and the landscape. And first of all, I please my brilliant experts first that they introduce by themselves. Cecilia, maybe you start.
First of all, hello everyone, and thanks for having me here. So my name is Cecilia Correia, and I'm a water solution manager at Bentley Systems in the industry water solution team, and my background is that I'm a water resources engineer.
Thank you very much for that. Gerhard, may you introduce by yourself?
Yeah, I think you probably heard my presentation. So I'm a landscape architect, but of course we have a lot of expertise in our team regarding water management and how this can be integrated especially in the urban setting. So we have a lot of experience of building.
Thank you very much. Thomas, please go on.
My name is Thomas Grönig and I am Managing Director of HST Systemtechnik in Germany. Our company designing and manufacturing key equipment for urban drainage infrastructure and also having quite a lot of software solutions to tackle all these challenges.
Thanks, Thomas. And now Scott, please go on.
Hi, I'm Scott Jeffers. I work with Sempergreen in the USA. I have a background in the digital space. I have a background in green stormwater infrastructure. We do a lot of work bringing these blue-green concepts in major urban centers. We work with a lot of engineering companies. We work with regulators. We get a really large boots on the ground perspective of how to bring these ideas into actual projects. So it's a really exciting discussion.
Thanks, Scott. And last but not least, Andreas, please tell us a little bit about you.
Thank you very much. My name is Andreas Vetter. I'm working at the German Environment Agency and there at the unit Compass the Competence Center on Climate Impacts and Adaptation. So our main role is to give policy advice. And therefore, I'm working at the assessment of policy instruments, so mainly before it comes to implementation. So that's also called ex-ante assessments. And since about 2 years, I'm focusing my work on the sponge city concept. Thank you very much.
Thanks for that. So our panel, we want to go into this 3 topic Boris mentioned in his introduction. And as you see on this slide, and maybe you heard it before in the presentations, the sponge city concept and all the strategies to get resilient cities in the future. We have a lot of topics and challenges on the left side, and also we have here also some solutions on the right side, and we want to bring this together. And in between, we have the cities and the people who are working in the municipalities with their daily business and also facing multi-crisis. So they have a lot of things to do. And we want to try to point out some special aspects to go more into detail in these different challenges and solutions. And we want to hear about the different perspectives and options that our experts has for this different challenges. So these 3 topics we have, and we want to start in each topic with statements from each expert, and then we go into the discussion and try to go deeper into that. So first of all, we start with the climate resilient urban planning. And I think it is very important to start with the first point with a good strategy and think about what is needed for a good planning. And now I want to start with Cecilia. Maybe you bring us your first statement of that.
Well, I think planning and managing a resilient city is all about making it safe for people to live, but also to improve the lifetime of our infrastructure while we improve the city's mobility. I mean, this shift between the impervious cities into connected green and blue infrastructure is not only about reducing the impact of rain, I think, but also constitutes a real opportunity to connect to the essence of our planet, which is water. Of course, I'm suspicious since I'm a water professional, but it is the truth. I mean, our city started being developed many years ago, and the big increase of cities came in the time of the old engineering mindset, which was based on eliminating all water. I mean, but today we know it is impossible to construct cities that can remove all the water in face of extreme events, for example. And I mean, we have all seen this. So we need better planning at watershed, basin level approach for correct water balance and account of future scenarios. I would also mention the importance of solutions that connect the infrastructure. I mean, siloed solutions, as we have all heard, they rarely solve any flood problem. They can act as drainage systems for light rain, some events, but they will fail, in face of extreme events, as we have all seen.
Thank you very much for that. Very interesting. Scott, can you tell us a little bit about your experience and what is your statement for the planning of this resilient cities?
Yeah, so it being Thanksgiving, I'm probably the only American on this call right now, so I can represent the philosophies of the United States. Generally, the stormwater management philosophies in the United States are very strong, and particularly from the site scale development. If you're trying to develop a site, whatever city that you're in is going to have strong regulations for both the retention and detention. With our work with Semper Green, trying to bring better green roofs with detention elements, we often run into the problem of what is the typical design look like? What does the typical regulation look like to get these systems in place? So one of the greatest things that I've learned in this line of work is how do we bring the green philosophy into the typical design process? How do we make this this is what typical business looks like? And it's the type of philosophies that Gerhard was talking about. It's building relationships. It's working together and listening to people and being able to speak the same language. And then once you start going down this path, you realize that a lot of the hurdles that are involved with green are based upon a perception of it being difficult to do. So I'm really proud that we've been able to achieve quite a lot by bringing these green elements into cities.
Okay, thank you very much for that. So we go later a little bit more on that detail. But first of all, Andreas, can you tell us your opinion to that, your focus?
Yeah, we see that's a challenge for cities to implement such sponge cities concepts into the existing structures. This is much more easy. Just if you have new developments, then you can start from the beginning. You can plan effective blue-green infrastructure. So that's much more easier. But if you look at these existing structures, that's not so easy. So solutions needs to be found for that. More dense structures in cities as well. So there are different aspects I want to highlight now. So it's necessary to develop integrated concepts that also consider the urban mobility, that it is necessary to tap into unsealing potentials of a city and to look at multifunctional ways to use the space in cities. And yeah, that's very important from my point of view, or from our point of view. And a complementary approach could be to integrate criteria for incorporating sponge city principles into urban planning, and also use these landscape architecture competitions to integrate such criteria from the beginning, that there will be developed such solutions that think on more urban green and blue infrastructures.
Thank you for that. So in the focus, you say integrated concept. Thomas, is this also one aspect of your basic view?
Yes, of course. Integrated concepts are extremely important, and I believe a comprehensive approach of the integration of green design concepts, that means dealing with reducing the runoff into the drainage system. Secondly, the gray design concepts, dealing with the collection, storage, and conveyance of stormwater to the wastewater treatment plant, respectively, also into the receiving water bodies. And number 3, that is a little bit special also for us, the digital design concepts, dealing with smart management platforms and monitoring and managing the entire stormwater and infrastructure. That is really essential for a resilient infrastructure. And the networking of these 3 design aspects, so that means bring them together, this should be considered right away in the urban planning. That means in an early stage of the urban planning process, to ensure a long-term resiliency and efficiency. And from ours and also my personal experience, that is not always the case. But anyway, already today, industries, companies, also like ourselves, we are able to provide the necessary technologies like smart machines to be installed in the gray infrastructures, and IT software solution for the smart management platforms are already, yes, they are already available. So just bring it back to the point, the integrated approach is very important.
Thank you for that, Gerhard. As a city planner with long year experience, what is your personal view to this resilient infrastructure from the planning view?
Mm-hmm. Yeah, I think a lot has been said already. It's really about changing the processes. I think this is really key. And in my opinion, we also have to understand that our cities have to become much more dynamic cities, so that when certain events happening, and we have extreme events, and in the last years we also see super extreme events, where it's almost impossible to plan for these events, but at least we need to have an idea how we deal with as good as possible, and to change a process within a city, how to deal with water, for example, is really a huge task. It does not happen by saying, hey, we want to do it. We are consulting a lot of bigger cities also, like we did Singapore or Copenhagen or Zurich or Basel, Switzerland. And really it's a human process to, first of all, accept that this is necessary. Secondly, how do I have to change my little stone, my little piece of attention in the system? And what do I need to know when to get to different solutions? And the second topic, in my opinion, we have an underground gray technical infrastructure, and now we add to this the green nature-based solutions. I think it should be possible to really extend the resilience of our city and combining this and thinking it technically sound and intelligent together. So in my opinion, a lot of opportunities there. There's always a little bit of, let's say, hesitation that the engineers and the softscape people like myself are collaborating on this topic. So, but I think opportunities are great.
That sounds good. So you mentioned the gray infrastructure and to combine it with also the green infrastructures. Thomas, sometimes when I read the literature, I'm not sure. So I have the opinion that there will be a kind of competition between nature-based solutions and the gray infrastructure, but you were deeply involved in that. Can you give us maybe an example how to combine gray and blue and green infrastructure, Thomas?
Yes, I mean, as I said, the integration is very important. And if it comes to make the overall or the comprehensive infrastructure more resilient, that requires storage space for the stormwater, because these are not, of course, the distribution is not equal. It's going up and down, and nobody knows when and where and how much stormwater or rain will fall. So that means we need to generate storage volume, and often there is a lot of available space or storage space, but it's not really activated in a proper way or entirely. For example, the green areas and the roofs, they store a lot of water, can store a lot of water, and often they just have a kind of a static flow control, so that makes a delay into the sewer system or into the drainage system. So just by replacing, for example, the static flow controller or flow reducer, so to say, there could be installed dynamic flow controllers to integrate them into the whole system. That means to store the water a longer time in these green areas and just release them when there is hydraulically space or hydraulically conditions allow it to release into the drainage system. But also it could connect it to weather forecasts, to weather conditions. For example, if the forecast predict the next 48 hours or 72 hours high period, a dry and a very hot period, why then just releasing the water or the water from the green areas into the drainage system? So it could be delayed, it could be controlled by other information sources, also IoT and from other sources. So to use this space, this above ground storage space together and combine it with the underground storage space. So that could be, for example, one of the approaches.
Thank you. But this sounds complex, Cecilia. You talked about better plannings, and maybe also we need a better mindset for that.
Yes, please.
Yes, Cecilia, please. Yes.
Yes, I mean, we need all of it, right? And it also starts with the mindset. I'd said that, the good hydraulic engineer in the past, had this old mindset, which would be to eliminate all signs of water. That would be like the perfect hydraulic engineer. And that's why we build these big pipe systems. We covered the rivers with, and we eliminated like small streams. Another thing we did was that we narrowed riverbeds, thinking that we could improve, economic development, like we're decreasing the space for this water so we can actually develop our cities. I mean, all that space available, right? Just for a floodplain. Everything was solved with concrete. What we did is that we failed to understand the importance of this natural blue infrastructure, which is constituted, we know, by streams, floodplains, but also the small streams and, of course, the permeable soils. Planning was very siloed. So planning was done based on what do I need? What is my interest? Even I participated in that type of projects. At the time, I had law from my side. I had to say you cannot delete or eliminate some of the streams. I think what we need is more partnership work that people have been mentioning here. Because I think today we can do much better because we actually have, for example, technology to support this cross-sectorial planning. We don't need to build actually to discover later that it doesn't work or that we have failed. So I think the first thing that we need to change is this idea that space for water to flow is wasted. It is not, and we have seen that water comes and just takes, its place, and everything will be damaged. So better and smarter planning requires collaboration and the understanding of the impact of our decisions in other areas. I mean, smarter planning will decrease the time of project. It will allow us to choose the best solution. It will allow us to understand the risk of picking each one of the solutions. And of course, this will decrease the cost of the project that I have been hearing also, during these sessions. What about the increase of costs? But it will improve the stakeholder engagement. That will definitely improve the resilience of our cities when it comes to water, making them more water wise. If we think about globally the costs of damage that occurs in cities, 69% are due to stormwater damages aspects of things. So connecting the green blue infrastructure into the gray infrastructure is not even something that we think, oh, maybe we'll do it. It's something that we need to. We just experienced some severe floods in Spain, for example, and we have seen that people went out and they demanded an answer from those who should be protecting them. So meaning that it's not just all about money, it's also about creating really safe cities for people.
Jeff, you mentioned that we need a typical design, all these aspects, what Cecilia and Thomas said. Is this part of that? And what do you see in the US? Do you have this typical design?
The typical design in the US, I mean, it often depends on where you are. If you're in a suburban landscape, there's space to do a lot of greening using your natural site, using the natural topography. When you get into a city where lot space is really tight, really expensive, that's when you start getting into talking about green roofs, when you want to start talking about how am I going to get green infrastructure involved. The typical design in the US, most of the design is still being conscious of the greater conveyance system that goes to the cities, particularly in places like Philadelphia, New York, that have a combined sewer system. So this is going to be a commonality between Europe and the United States. When you're so concerned about the amount of water going into the combined sewer, which can then release untreated wastewater. Untreated wastewater is one of the really critical elements about this. It is one of the greatest drivers for urban greening and stormwater management in general in these older cities. So we are often in competition with a detention requirement, a tank with an orifice in it. We have to slowly release the water, but we can do that really effectively. It's really easy to understand. It's really easy to model. It's really easy to regulate. And you have one spot that you go when you evaluate and maintain to look at. When you start talking about green systems, they're a lot more potentially dynamic depending on how you design them. They're potentially harder to evaluate if your regulatory framework and your engineers are trained and used to permitting and designing these types of systems. So if you can show that making one step forward into thinking about these green solutions is aligning with the previous philosophy, and we're able to regulate and we're able to evaluate them using the same tools that we've been doing for the previous methods. It becomes a much more tangible step forward in the narrative where you're not asking necessarily too much. You're just saying, I will show you how this works in the way you're used to seeing things.
Yes, that's right, Gerhard. And you mentioned the dynamic city. When you hear all these different aspects, how we come to that?
That's a good question. I think Scott had a good point, because I think this is also a big hurdle, a big problem of our concepts, that they are so decentralized. They are sometimes very small, and they also affect kind of the surface of the cities. And then you have to talk to all the different agencies, to all the different planners, transport, energy, infrastructure, architecture, and this makes this quite complicated. But I think we have no choice, in my opinion, because the relationship between water, soil, and plants is so essential for our cities, for the solutions of our problems, of heat problems and drought problems and flood problems, that at the moment I'm not aware of any other concept that really addresses these issues. So, and this all means there's a lot of dynamic. Water needs time to stand there and infiltrates within 2 hours or 4 hours or 6 hours. And this should be acceptable. And also plants are, in our climate, is sometimes green, sometimes not green. There's also a dynamic in the plants. So, and this, we as a civilization, we have tried to neglect this or push this out. But to bring this back, I think this needs a lot of communication also, or learning, or seeing what are the positive aspects. And this brings back the dynamic, and this brings also back a lot of health for ourselves. And this is what we should, put in the foreground, and then maybe more dynamic is possible.
Yes, I follow you, Andreas, and you have this more meta perspective from a governmental organization, and also some question is coming from the audience, from Stefan Grummel from the KfW Bank, and the problem is the existing infrastructure, and it's very easy to bring it in new areas and new quarters. So from your perspective, Andreas, how we come to this, to bring this together, and which are the most challenges in that process, especially when we are in existing infrastructure?
And of course, that's the challenge. There is just to start also with these small solutions, so small flexible solutions, to look at these low-hanging fruits. So what can be done, and how we can bring different actors together. So we looked very much what can municipalities do just to enable also other actors. And Gerhard just spoke about this learning from each other. I think that's a very important thing, to try things out, to learn what are others doing, but what is working in another city and what can be transferred to our city. I just want to bring a concrete example that is referring to the point that Thomas was talking about, the storage of stormwater, and there are already municipalities that implement such local ordinances for the local how is it, the local ordinances to support small city concerns and urban planning processes. For instance, these local cistern ordinances that can mandate the use of cisterns for stormwater capture and reuse in new development and larger redevelopments. And in Germany, the federal state of Hessen has prepared a template for that, for the municipalities, so that municipalities can adopt the template from the federal level for their own use. And there's an advantage for the community, because they have then less fear for legal uncertainty. That's always a question that municipalities have. If I implement a new regulation, is it certain enough, or will we have problems with that? So that's I think it's a very good example of how can different levels work together. In this case, the federal, state level with the municipal level, and to enable other actors. Just to give one example.
Yes, so we see in these statements and answers we have a huge complex to come to the resilient city, and I want to use one of the next questions from the audience. This is from Mitra Nikpai from Satonic. He asks about the influence of microplastic when we talk about water. Water pollution also in a sponge city when we have overflooding. And I want to use this question to come to the next point, to the digital part and the technical solution. Thomas, I know that HST is also working with our university in this topic, and we try to avoid the outcome of microplastic by holding back volume. How you do this with the digital solution as a part of a smart sponge city?
Okay, so that is mainly related also to the combined sewer system, where there have certain so-called CSO points that overflows if the hydraulic system cannot take the stormwater. So that means this water is a mixture that flows into the receiving waters, consisting of sewage and rainwater. So now the question is how to retain most of the solids or the sediments into the system rather than be discharged into the receiving water and causing their severe pollution, including microplastic. So, and we have developed fine screens. That is already quite common technology, but we attach kind of a certain software. We call it screen software that allows to significantly increase the filter performance by generating an artificial filter cake. So that means this filter cake is then generated, and it can even hold back microplastic. That means from rubber pieces from tires that are flushed from the streets into the drainage system and so on. And that is a good example of a smart machine that can be installed in the system. And you're right, we are just doing the scientific evaluation and effects with the University of Hof together. But this is one example. There are certainly some others also from other companies that have certain good technologies to tackle this microplastic issue. But in our terms, and if it comes to sponge cities, it's one big thing is just to retain these substances, this microplastic or also plastic, from penetrating into the receiving waters, hold it back in the system that it can be taken out in the wastewater treatment plant.
Okay, thank you. So we see that we come from the holistic view now in the very detailed view with the digital solution. So when we go now from the underground to the top of the roof, Scott, the importance of digital solution also for the rainwater management as a big part or a main part of sponge cities on the green roofs. What is your perspective of that?
I think one of the important concepts, and it was touched on in Gerhard's presentation, was hydrology has scales. There's the big watershed scale with the rivers and the dams. There's the city scale with the floodplains and the conveyance networks. And then there's the site scale, people that are working on developing a plot. That is the scale that I'm focusing on now. We see a lot of conversation about the planning level in this discussion using larger hydraulic models, and we can use those in order to figure out planning. We can use this to size pipes. We can find hot spots for where green makes most sense. We can use those to evaluate floodplains. But it's important to recognize that a lot of the design is going to go on at the site scale, and these larger type of models are usually not in the hands of the typical engineer or the typical regulator or permitter to be able to understand how to evaluate sites using these more sophisticated techniques. So as a result of that, it becomes really important to any time these digital solutions come into play to keep in mind that it needs to be available to the folks that are out there building something and be able to use those to inform the designs. And then likewise, make sure that any of these types of techniques are going to be able to be reviewed by somebody that's going to put a stamp of approval on any of these sites. Because if these methods are too complicated, then you start shutting down the conversation right away. You already start talking about doing something green that's a little bit different. And now you start talking about evaluating it using a sophisticated technique. And now you start talking about a regulator about to evaluate it. It becomes an unnecessary hurdle. So that's why one of my key points is that it's very important to be able to be compatible with the existing regulatory and engineering practices when trying to bring these green solutions forward.
Yes, and Andreas, this is, I think, maybe also a discussion in your organization, how to handle these regulations, the old ones, and what we need, the new ones. What do you think we need, or what plays the digital solutions also, not only in censoring and also for planning the digital tools? What do you think is important also to use old and new regulations on that?
I would just say, not from the part of regulations, but general, we need better data and information basis for the implementation of the sponge city. I think that's clear. So municipalities are acting often very unsecure about if I really implement a measure, is it really effective? Is it cooling down a quarter enough? Do I need complementary measures, etc.? So they need more data and information to really be able to speak about is the measure working, and is this investment really working in the end. And there it comes to the new concept of digital twins that are being used. So we think that's very important. So they are the first model project also on national scale about digital twins, and it's important to use them and also to get more information out of these tools about the effectiveness of measures that by continuously simulation, and this reduces in the end the uncertainty. For example, how effective are the measures even under different extreme weather conditions?
Yes, so these are very important aspects, Cecilia. I think you can imagine that. What is your perspective of that, especially when you are looking as a general planner on a strategy for a city, for example? How do you use a digital solution, or how do you recommend using this?
Touching upon some of the questions that have been asked, and Gerard mentioned, for example, old cities, and that had really good results. So the thing and the reason why people say, I cannot do it because it's so old, we don't have space. I think it's because people are not actually taking all the advantage of the information that they have. So one of the first aspects that I would like to maybe mention, I mean, all of us know this, but we have this sense that my city doesn't work because it's different. I have to say that cities are all dynamic. You know, they continuously evolve. They're connecting diverse systems, needs, priority. All of this is always changing. So I would say that to function effectively as one integrated and, you know, green and blue infrastructure, we need really to adopt the technology. I mean, it is essential, and I think it's not even negotiable for the future. The digitalization will play the key role, because I was listening to my colleagues here in the panel, and what I hear is different perspectives, different levels of understanding. So I think it comes from stakeholder engagement to actually start incorporating all of this information. All of this information is being siloed today, but they can, I mean, today, because, you know, there's all this process of digitalization. The world has become digital. And so we can actually make use of most of this data, bringing in, and as it was mentioned, the digital twins really have this possibility to create this digital copy. So you can actually bring information from different projects and see how at a city scale it will work. So maybe, a certain project that you want to implement will not be able to solve a certain flood, but if you bring them all together, you may find some spaces where you can actually, reducing a peak flow here, reducing a peak flow there, implementing a floodplain area where you have a park. You can actually take a lot of advantage and value from that, from using these digital solutions and tools that are available.
Exactly. You mentioned this silo thinking mentality or doing in the daily work, Gerhard. You when you were starting such a project in your office or with your company, often maybe you start with a new quarter, but it's a part of a complete city. How you are confronted with, I think you work local, but more or less you have influences from the complete city. How you handle this and how you use digital solutions.
Yeah, that's right. So the first thing we do, we always look into the watershed. So we are not just looking at our site, we are looking into the watershed. Hey, what happens where? Where can I find a better solution maybe than in my dense little spot? Maybe there are somewhere else other better solutions, and at least we can propose this or point to this. And then we try to find the right solution for the aspect or problem of this individual plots that we are dealing with, that we don't create a greater problem somewhere else, that we are part of the solution. And but going a little bit away from the individual project, we are working at the moment really closely with the city of Zurich to get rid of some obstacles and also to give clear guidance. So our idea is to say, okay, first of all, we want to change the mentality. So, one little thing, green should be at the lowest point of a certain area. So look at the streets. Typically, we do a curbstone around our trees, so they are protected from the water. But we can change this. So this is the let's say the the general aspect. And secondly, we are developing at the moment, let's say we call it the rainwater calculator, that every property owner who let's say intend to change his property or his site, he wants to add another building or do a change of the site, so that he gets a really clear tool to say, okay, this is my goal. This is, let's say, close to the natural water balance of this area. I'm in a city center area, so of course I have some problems. I cannot achieve the full water cycle, but a little bit reduced, maybe 90% of that goal. And then we have what we call the rainwater calculators, that he gives in his plot, and he also gives in the measurements that he is doing, and then he gets a result. So he can say, okay, I do permeable surfaces here, I do a green roof there, I do this and that there. And, we just want to make it super easy, first of all, for the applicant, and secondly, also for the permitting agency. So if you have, let's say, one line of information, one digital source of information, one digital point where everybody, the one that does the application for a certain site. Secondly, you get the information about what is your goal. And third, the city can also give the permitting quite easy. If you centralize all of this together, and that's our goal, we need a year more, I would say, but we are on the way. And these are the steps that it should be as easy as possible to get to this. I think that's one of the key topics.
Yes, this looks like a holistic working concept. And I think you were successful with this. Scott, when we look to America, now we come to the third topic of we have to finance that. And also we have to go on with rules. You mentioned that, Scott. How do you work with this when you try to convince the investors of a building or a quarter that it is interesting to use your solutions, or using in general sponge solutions?
So one of the cool things in working in site design is that every project is different. What we found is that green roofs economically they make most sense in dense urban settings where there's limited space. Reasons why people would use a green roof. A lot of people they want to be green. They appreciate the triple bottom line. They appreciate all of the other benefits that come with green outside of a stormwater regulation. Stormwater regulations, however, are the main driver in the United States for why somebody is going to be looking at that. These are the boxes that need to be checked. But there's been a lot of really interesting points that have come up. A lot of the times it is a lot cheaper when you start factoring in other costs. For example, if you have to start building an underground tank on a site, you now have to excavate. Because you're now building with the foundation of the building, that can delay the entire project. You have to wait until that groundwork is done. You have to wait until that tank is installed. You have to wait for it to get approved and permitted. If you start talking about even a larger parking lot, you have to now, if you have a big basin, you're saying, I'm comparing my big underground basin to my green roof. Not only is the cost just the basin, you now have to put inlets in the street. You have to dig up and put pipes and conveyance system in order to get all of that to the site. If the site has any type of contaminant in the soil, that has to be dealt with. So a lot of these things end up if you just do a line-to-line comparison, the green can be more expensive. But when you factor in all of the elements, it's often that this isn't necessarily a matter of we need to come up with money for this. This is the financial decision that you should be making. And of course, it's site to site.
So this means we have to show not only to get new money for new concepts, we have to show that we change to new concepts to save money for new concepts at that point. And Cecilia, this we have to implement in our daily consulting, and especially to bring this into the daily work. And we have to also to change a little bit the workflow of daily business. Do you have some ideas how we can handle that?
I think one of the first aspects that I would like to mention is that whatever regulations we have in place is what brought us to where we are today. If we want to do things better, then we should start also by the regulation, because many of the mistakes were done in accordance with regulation in place a couple of years ago. It comes again, the aspect of continuously being evolving. And the other aspect that I would mention again, because I think this is really important when it comes from a holistic perspective, is the part with more collaboration between everyone. I mean, I strongly believe that becoming more resilient is not more expensive. It may look like, but whenever someone tells me this is more expensive, I usually ask, so how expensive is the way they were doing things today? People are not comparing both. They are just talking about the new money that they will have to spend. But we have already seen how expensive the mistakes from the past can be if we don't take in account, the watershed level management that, for example, Gerard was talking about. I would say that, for example, and pushing a little bit the technology, because it's one of the things that we see across all the industries. If we think about the collaboration that is needed, for example, from a municipality, and if we're talking about at a city level, we can imagine the quantity of departments involved. And having a flood is not only about the water infrastructure, is avoiding that, for example, transportation, for example, gets flooded. This means a lot of money that is not being brought to the equation when we think about the costs. Maybe the costs of more resilient water infrastructure needs to be shared between other areas, like the transportation, like the energy, even the water supply. We have all seen that when there's a huge extreme event and there's a big flood, the energy gets, we have a shutdown of energy. And this means no energy, this means no water distribution. This means that people have no energy, no water to clean, and their lives have been affected by mobility. They're not even able to go anywhere. So maybe what we need to change is also the way that municipalities are actually engaging when it comes to a water infrastructure, meaning that everyone is affected. So maybe we need to share responsibilities, work better together to plan better for the future.
You're right on that side, and we see that we have to integrate this more or less into the daily work. But Andreas, I often see this. A lot of people want to do this, especially on that side, who have to follow the rules, the current rules, and we have a little bit conflict because the new rules are not coming so fast. And sure, we have a lot of development on the legal side. But what is your impression on that, or your experience? How we can go faster with this, or what maybe we can go a parallel way to bring this faster into action? Do you have some aspects to that?
Yeah, first I would say that we give policy advice to change regulation and rules because it's necessary that the framework is getting better to really support the transformation to more blue and green infrastructures in cities. And there's a lot of success. So in Germany, for example, we have this new climate adaptation law in Germany since July this year. So now also municipalities are required by the federal states to draw up climate adaptation concepts. And I think that's a very important start because now municipalities have it on their agenda. They have to act in that direction to provide more adaptation solutions. And of course, on the other side, it means we heard it, it also means financing. It's not just all restructuring of existing financing. It also needs more financing, and therefore the federal government and the federal states are looking for a joint financing scheme at the moment to better support municipality. And on the other side, we see it also on the model projects that are also that are already developed, that the framework is sufficient to go on with these solutions. It's not we can't say that the framework doesn't work at all. So it's possible to start to use what is possible already at the moment, and there are there are there are a lot of possibilities city can use. They can just start to bring more green into the cities, and they can just build these joint projects with institutions, with university to go on and model projects. So there are already financing schemes there to start with, and yeah, there's no reason to wait, I would say.
Yes, you're right. And we have to bring more green into the city. Gerhard, what is your experience in these, especially in this conflict between existing rules and also existing infrastructure? Can you use your module for that? That is helping us to force this problem, or not the problem, the solution. Sorry.
Yeah, financing is a big topic. I mean, what value do we give a healthy water system in our cities? And it's just a societal question on the big scale. And I think a little bit back to Copenhagen, where there was really made a business case. So there was also, let's say, a rough calculation. They had a flood event, 2011, 1 hour, damages of 1 billion euros. 1 billion euros. And later on, within our process, we did a calculation that if you would have invested 500 million euros, you would have been able to, you would not have this 1 billion damage. So it's really also a very wise investment. But of course, where does the money come from now, today, in this project? Where does it come from? That sometimes it's not there. And I'm also, sometimes when you mentioned green on facades and roofs and so on, sometimes it's just too expensive to do it, and then it's better to find solutions somewhere else. I would always start more on the surface and then think about what can we do on buildings. And of course, the green roofs makes a lot of sense if you do new ones, but we also have many other aspects. Like infrastructure or solar panels, and how do you bring this together? And it's another big discussion. But our tool, we really, when we make the assessment in an early planning stage about what nature-based solutions is the best one or the most efficient one, of course, we also look into installation costs and into maintenance costs in the long term. So this is an information that needs to be there, that needs to be visible to understand, okay, if I do this, it has that effect on costs and that effect on in the long term. Because in my opinion, if it's a low-tech solution in the long term, it's always cheaper than all the technical solutions. And I think it's like with everything. We have to deal with it. We have to find solutions. We have to convince on a project level. We have to change regulations. It's like a myriad of little steps. But again, I can just think that it makes all sense in the world to go that road, and I think we are on the track. So we just have to be a bit patient. I think it will be a nice future.
You're right. So you're just in the future perspective on that. But before we come to that, it's a good bridge for the last statements. Thomas, we also had one question from the audience again from what is the name? Sorry, from Mr. Nick Bay. He's a little bit, how can I say, concerned about too much digitization maybe that we are following. And also this is also connecting our financial aspect. And regarding this using of digitization in existing infrastructures, so can you tell us a little bit about the project of Jena, where we together improve existing sewer systems by less investment and have a big effect?
Yes, I can certainly, and that also I carefully followed Scott's opinion on this, and he's totally right. It should be before digging in the ground, and which is very expensive and also extending the timeline. We should make a better use and a more efficient use of the existing infrastructure. And in case of this Jena that you just mentioned, city of Jena, we implemented there just by a digital solution, by a smart we call it an IntelliNet software, to connect the storage structures like various storage tanks, underground retention tanks or storage channels together, exchange information and even connect them to a very high resolution rainfall forecast that tells the system exactly how much rain when is going to fall and how much dirt load and hydraulic load is rushing into the drainage system. And then it calculates, for example, the necessary storage volume to avoid flooding and also spillover or emergency discharge in the receiving waters. And then it distributes the and controls the storage value in a way that discharge will only happen if more or less 95 or in the best case 100% of the available storage volume is utilized. So by doing this, by applying this, so we need this intelligence and digitalization solutions. And we need some smart machines like intelligent flow controllers and so on to install in the system. And by doing this, this calculation has shown and proved that in the city of Jena, about 12,000 cubic meter of additional storage volume could be utilized without doing any civil construction. And if we transfer this to cost, so in Germany, roughly 1 cubic meter of storage space, underground storage space, creates cost of about 3 or 3,500 euro. So we can easily calculate how much cost saving has been generated. So it's about certainly more than 30 million of cost saving. So this is a typical example, and yes, an actual case that proves that digital solutions are able to improve the resiliency of the drainage systems, yes, in a whole.
Yes, thank you. Maybe as additional information to understand it, the civil costs more than 30 million euros, and the technical installation is between 1 and 1.5 million euro.
Yes,
so
right.
This is a
Thank you.
comparison. Yes, so this is a very good leverage. I have one question from colleague Professor Wolfgang Güntert from Munich, and he is asking: we have a lot of solutions for sponge cities, and we know about this, and I mentioned also this conflict with the existing regulations. Maybe, Andreas, you could answer the question: do we need new regulations as we have so much solutions for solving?
I think we should really look at the existing regulations. What is hindering us in implementing sponge city concepts, and where do we need change? For example, the Federal Water Act in Germany. So I think there's improvement to really see water as a resource and to implement that much stronger, to foster these local retention aspects more strongly in these countries. These are some examples. Also, the National Building Act. It's at the moment there's a draft for some changes that are really going in the right direction to support green-blue infrastructures in Germany. So hopefully that will be implemented, and we see that there are quite a lot of aspects where we should change regulation, but the existing planning instruments. So what I heard also from the planning community is that they are sufficient, that we really can act with these conditions in Germany as they are at the moment. So I would say we should also look at some more softer instruments. So how is it? Will we have enough expert in future to really do all the work to build our green-blue infrastructures, to build these sponge cities? So we have to look at education, also bring younger people into this into this field, and that they really engage for these new type of cities, I would say. And so that's a very important point, I would say. And then, of course, the data aspect in the end, hopefully it will be will be a big help to make the work more efficient and to connect the concepts, the different concepts better.
Okay, thank you for that. So the time is nearly at the end. So at the end, we see that it's a very holistic and multidisciplinary and multi-complex topic, and we face a lot of challenges in the future, but I think we have a lot of ideas, a lot of visions for that. And finally, I please you a very short statement, 1 or 2 sentences, what you think regarding the title Urban Water 2030. What is needed and what is your recommendation? Cecilia, maybe you start for that.
Okay, so I would recommend a more collaborative environment. We have all seen how how inefficiency is related to the lack of collaboration between all the areas. And if I would think about the future, it has to do with the connectivity of the system. We're all working and we're not working together. We're duplicating efforts and work. And the only way to really achieve effective solutions and effective managers will be through collaboration. And technology is really the aspect that will connect all the areas and will allow us to test, to monitor, to understand in real time what are our solutions working, which solutions are working better and worse, and what are the ones that we need to achieve. Also for stakeholders engagement, which is really important in all of these change. They really need to understand, and I think having virtual reality of what is happening is really important for them.
Thank you very much. Scott, what is your recommendation for the next years?
I guess I'll just jump on the back of Cecilia. Yeah, collaboration, absolutely. Talking to people. Find me on LinkedIn. It would be great. We were joking as we were putting together this panel discussion that we would not have enough time to address. We could have each conversation topic be an entire day or an entire hour. What are my recommendations? I think everybody is moving in the right direction. I guess I'll just second Cecilia's point. Let's keep talking and let's keep figuring it out.
Thomas, you have an additional point of that we have to take care about for the future?
Yes, I mean, as I said already, it's all about utilization of storage volume. I would also recommend definitely an integral approach of green and gray design already in an early planning stage, which is not always happening. So we should focus on this. And if it comes to technology, yes, we need to apply digital solutions. And from our area of activity or how to say expertise, we need to replace the unknown variables with known variables. So that is what we're doing and what is our daily business for an intelligent and highly efficient operation of a drainage infrastructure in a whole that includes green architecture or green design as well as gray design.
Okay, thanks. And Andreas, what is your final statement for us?
So they were already said so much important points. I think this collaboration aspect is very important. Also the involvement of the citizens, of the people who really live in the cities. We already talked about that in the panel discussions. So I would strengthen that topic because I mean, we will have to challenge to keep these long-term perspective of climate change, of transformation of the cities to more blue-green infrastructures. We have to keep that on the agenda, and that won't be easy all the time. So we all have to work together because we can only maintain the quality of life in cities when we go on this way. So thank you very much.
Thank you, Gerhard. You have the possibility to close the circle with your statement and bring us into the future.
Okay, then let's do it short. I can only say, 30 years when I started this work, we had been freaks, really. We had been seen as a little bit outside of the norm, and now we are mainstream. It's not the question anymore that we need to go this direction. So I think it's on a good track. We just have to be patient. And I can just say, don't forget the emotional aspect. And, we have to bring soul and body and technique together. And I think that's a bit lacking, that blue-green infrastructure also has to be sexy. Then I think it's successful. Thank you.
I think this is a brilliant final word. And thank you, all of us, for this very interesting panel, and I hope we bring some good aspects for the audience. And thank you very much for your time and your good statements in this panel. Thank you very much.
Thank you.
Thank you.
You did, Günther, indeed. Thank you very much once again to our host, Professor Müller-Ziegern, and our panelists, Cecilia Correra, Thomas Grünig, Gerhard Hauber, Dr. Scott Jeffers and Andreas Vetter, for such a rich and engaging discussion.